In this module, we have talked about the business models that could be used for industrial internet and industrial IoT scenarios. In this particular lecture, we are going to talk about the reference architecture. So far in the context of the business, we have talked about the possible business models that could be used in the previous lectures in this particular module, but we should be also able to use the different architectural platforms for transformation of the business for the adoption of industrial IoT. So, let us look at the IIoT reference architecture. So, the IIoT reference architecture is governed by the industrial internet reference architecture. So, this is sort of a standard architecture that IIoT systems globally tend to use and tend to follow. So, IIRA, Industrial Internet Reference Architecture, is the architectural standard that is used for most of these IIoT applications in these industries. So, it is a standards based architecture which was proposed by the Industrial Internet Consortium IIC. Their technology working group came up with this architecture. The current version of it is IIRA v1.8. So, 1.8 is the current version of the industrial internet reference architecture, and this architecture broadly applies in the industrial systems to allow interoperability, mapping application technologies, and in guiding the use of these technologies by different application users. So, for the IIRA, one of the central thematic concerns is the safety, and many of these architectural elements basically have been designed in such a way that safety has been kept in mind. So, IIRA safety concern is important, and after safety is the issue of security. So, security in terms of everything: security of information, security of data, security of the systems, and so on. So, safety and security are paramount and central thematic considerations while coming up with the IIRA architecture for use with IIoT industrial applications. So, in terms of safety, it is important to know for the system that is operating, what is the condition of it. It is also important to ensure that there is no unexpected risk of physical damage or injury to people due to some malfunctioning or potentially malfunctioning systems in the future. And third safety concern is to ensure that there is no damage to property or environment due to any kind of malfunctioning now or in the future. So, these are some of these KPIs for occupational safety and health. These KPIs are basically a measure of the activities of an organization. These KPIs also help measure the connectivity and communication with customers, providing valuable feedback to the customers, and driving towards further improvement. So, there are different KPIs. So, these KPIs based on their types can be categorized into two types. One is the leading KPI, and it is mainly used to predict the economy. It is input oriented and is hard to measure. And as the name suggests, the latter category is the lagging KPI, which is a technical indicator which changes after the economy has started, which has it has initiated. So, unlike the leading KPI, which is input oriented, the lagging KPI is output oriented, and this is hard to improve, right. So, basically leading KPI talks about predicting the economy, and lagging KPI talking about after the economy has started to improve, right, to improve. So, So, basically these two perspectives are different. So, leading KPI and lagging KPI are the two different KPI categories for OSH. So, leading KPIs, for example, percentage of managers with adequate operational and safety, health safety training, percentage of workers with adequate operational and safety training, then frequency of observed unsafe behavior, number of OSH audits. These are some of these different KPIs under the leading KPIs category. Under the lagging KPIs category, we have number of lost time incident frequency rate, how many times the different incidents have occurred and we have lost time due to those incidents and the frequency of occurrence of those incidents. Production days lost due to sickness absence, incidents or near misses and number of fatalities. These are the lagging KPIs. So, I was talking about the IIC, which is the Industrial Internet Consortium, which is a non-profit consortium doing different things, promoting open standards, standards for interoperability, supporting architectures of different architectures for promoting interoperability across different technologies and so on. And these technologies, open standards, interoperable standards, etc., these are used in industries and for M2M communication in these industries. So, this IIC is the one which came up with that IRA architecture, the Industrial Internet Reference Architecture, IIRA architecture. So, this Industrial Internet Consortium IIC has also among its focus areas and activities has the development of test beds for different trials, also a major concern. So, test beds are an area of major focus and activity of the different IIC members. So, Industrial Internet Consortium continues to do different activities, tasks and so on. They have their different working groups. So, these working groups do different things, they innovate, they come up with different opportunities of the use of new technologies, new applications, new processes, new products, new services, etc., which could be initiated, conceptualized and could be rigorously tested in the different test beds that I just talked about a while back. And these could be done before they are actually launched in the market. So, these are the ones, these are the different activities that are promoted by the IIC. So, II reference architecture, IIRA, Industrial Internet Reference Architecture, IIRA has different architectural components which are part of their framework. Number one is the stakeholder. So, we need to understand some of these different concepts. So, number one is the stakeholder. Stakeholders are individuals, teams or organizations having interest concerning the system. The next concept is linked to the stakeholders. These are the viewpoints. So, the stakeholders have some interest in the viewpoints and the system. So, viewpoints are from the stakeholders, which are basically the collection of different ideas from the stakeholders, collection, grouping of them, describing these different ideas, analyzing the ideas and solving the set of specific concerns. This is the TIRA framework. So, as you can see over here, let me just explain it to you. So, this shows that there are different stakeholder groups, stakeholder group 1, stakeholder group 2. These stakeholders have different have different viewpoints, viewpoint 1.1, viewpoint 1.2, etc. Similarly, stakeholder 2 would have their own viewpoint, which could be again classified as 2.1, 2.2, etc., as the case may be. So, that is the concept of the viewpoints, which is basically a collection of different ideas from different stakeholders. So, these stakeholders come up with different viewpoints, and these viewpoints essentially help in coming up with these different architectural components, architecture 1.1, 1.2, etc., and architecture 2 2.1, 2.2 etc., mapping directly to these different viewpoints. Next comes the concept of the frame, the architectural frame, which is a collection of ways which identify, describe and analyze the ideas of the different stakeholders. The concept of architectural representation is important. It is the collection of outcomes of architectural frame and are expressed as views. Different IIoT architecture implementation patterns have been proposed. So, we will go through 3 different patterns. Number 1 is the 3-tier architecture pattern. Number 2 is the gateway-mediated edge connectivity and management architecture pattern, and third is the layered databus pattern. So, let us go through each of these. To start with, we will first go through the 3-tier architecture pattern. In this 3-tier architecture pattern, we have 3 different layers. We have the edge layer, the platform layer and the enterprise layer. So, edge layer basically talks about all these different edge devices and basically the devices connecting to these different gateways at the edge and so on, and these devices and the gateways etc. are going to send the data to the platform layer. This is the platform layer where the data are going to be analyzed and so on, and further the data are going to be processed and sent to the enterprise layer. The control flow is in the reverse direction. Data could flow from the edge layer to the platform layer directly, or could directly also flow to the enterprise layer. So, this 3-tier architecture pattern, let us go through the different components in further more detail. So, we have the edge layer which gathers the data from the edge nodes. The architecture includes the breadth of distribution, governance and location of the data, breadth of distribution of the data, governance of the data and the location of the data, meaning that where from the data are coming from these individual devices. Platform layer, basically it is concerning receiving, processing and forwarding control commands from the enterprise layer to the edge layer. And finally, the enterprise layer concerns receiving data flows from the edge layer and the platform layer. Directly from the edge layer, the enterprise layer could be receiving the data, or it could be from the platform layer, which again receives the data from the edge layer. So, the enterprise layer basically implements domain specific requirements, decision support systems and other requirements such as interfaces to end users. The next type of architecture is the gateway mediated edge architecture. Here basically we are talking about incorporation of the gateway concept. So, we have all these different sensors and actuators. These sensors and actuators throw in lot of data, and through the different gateway devices, edge devices, gateway devices and so on, the data are sent to the wide area network for further dissemination of different information and so on. So, like the previous architecture, here again let us go through each of these architectural components of the gateway mediated edge architecture in further detail. So, this gateway mediated edge architecture consists of a local area network for the IIoT edge system and the gateway connecting to the wide area network. The local area network may use a hub and spoke topology or a mesh topology. Mesh topology is one where the different nodes are connected to one another in the form of a mesh. So, there are a lot of different links, redundant, and many different links are there. So, basically what happens is, if one link has broken, still the different nodes may not be completely disconnected from one another, because there might be some alternate links directly or indirectly which will basically handle the problem. So, the other one is the hub and spoke topology, which is very similar to the star topology, where you have the hub and there are different spoke. Spoke are basically connected to the different other edge nodes, and together you have a central kind of hub device connecting to these different other IoT devices, other edge devices and so on. So, this becomes a star kind of topology or a hub and spoke topology. So, you have this local area network which supports two different types of topologies, the mesh topology and the hub and spoke network topology. Then we have these gateway devices acting as the management points for the edge devices locally, helping in the transferring of the data, processing of the data and analysis of the data. The third type of architectural pattern is the layered databus pattern. So, one thing I should mention before we go any further is all these different architectural patterns are sort of like common templates which could be used in order to as reference architectures in order to deploy IIoT solutions in the industries. So, now let us go through this third architectural pattern which is the layered databus pattern. So, here we have three different tiers. We have the smart machines, then we have system of systems and the industrial internet. So, a system of systems is basically a complex system consisting of different subsystems together, working together, generating lot of complex executing lot of complex algorithm, generating lot of data, to be handled and processed to get lot of insights about what is going on down underneath. So, this is what is done by the layered databus layer. This is the layered databus. Then you have the industrial internet. We have these different applications running on the industrial internet, using the industrial internet in different industrial application sites, same site in the same industry, different groups or different sites of the same company, or it could be that different companies are interconnected together. So, this is the layered databus pattern which is different from the previous two patterns that we have just discussed. So, let us go through this pattern also little bit in further detail. So, here we are talking about use of smart machines. So, these smart machines at the lowest layer will help in local control and automation processes. System of systems layer allows complex systems to be executed, complex monitoring, complex processing and analytic applications, all of these things could be executed at this particular layer. Then you have the layered databus pattern which is applicable in the field of control, local monitoring and analytics, and the databus basically communicates between the applications and devices. So, this communication is enabled with the help of the databus. So, this communication will essentially help in allowing interoperable communication between different endpoints, between different machines, etc. So, layered databus pattern basically allows fast device to device integration with minimum response time, automatic data and application delivery, scalable integration of devices, availability of the system, making it higher, and hierarchical subsystem isolation. So, this isolation part is very important, subsystem isolation, because this will help in making the solutions much more scalable and adaptable. Adaptable to what? Adaptable to different changes. So, with this we come to the end of the first part of the reference architecture. So, we have seen that this IIRA reference architecture is sort of like a de facto kind of standard being used for the implementation of IIoT in the industries, and this connects well with the business model of this particular unit. In the business model, we have seen the different types of business models that would be adopted, and this reference architecture is the one which takes it further technically. So, it is basically this reference architecture is sitting between the business issues and the technicalities, and it is trying to map the business requirements with the technical requirements by providing different architectural solutions, common architectural solutions which could be adopted in order to deploy IIoT solutions in the industries. These are some of these references which you could use and go through further. You could also dig on your own to find out more different other references on this topic. Thank you.